Greetings to Dr. Basil. Today, my group and I from Group 5 and Section 2 would like to present our group project for Advanced Traffic Engineering. So, I will be the first one to start with introduction, and my name is Nada Binti Abdul Razak, and my number metric is the F200-144. So to begin with, the signalized intersection with controlled cross traffic light pieces tell cars when to enter intersection, and this will lead to decreasing collisions. This intersection use phase timing schemes to control traffic flow, and the coordination solution minimize delays in intersection and corridors. Signalized crossing have various configurations, which are left turn, right turn lanes, pedestrian signals, and option for permissive turns. And the concept creates the foundation of safe and effective traffic sign setting. We're moving on to the problem statement. The traffic congestion is caused by vehicles and traffic volume exceeding road capacity. Transport delays and safety issues are also caused by insufficient pedestrian facilities, poor signal timing, and outdated infrastructure. The traffic congestion has been identified as a serious problem at the Ninsu Junction, which we have chosen Ninsu Junction as our group project, and it causing accidents and affecting travel time. Our objective for this group project is the first one, to analyze traffic flow at the Ninsu Junction, which located in Jalan Keluang to Port Raja. The second is to determine the delay in level of service (LOS) suffered by drivers as a result of traffic congestion. And the last one is to improve the capacity and efficiency of road networks by managing traffic signal timing. So for my last part, which is goal of study. The first one is the primary goal of the study are to improve safety, improve traffic flow, and address developing concern. Besides, the geometric design of crossing are examined, especially how it affects safety and efficiency, which lead to providing opportunity for improvements. In addition, safety analysis based on collision data might decrease accidents, along with investigation of the effect of adaptive signal control system and new technology on intersection operation. On the other hand, environmental impact of signalized junction are also evaluated, and the last one is summary includes result and recommendation, along with an insight of signalized junction and ideas for potential solution. Thank you from me.
Hello, my name is Muhammad Haris, and I'll be presenting for chapter 2 of this presentation, the methodology. Now for the flowchart, we determine the study area, determine the data collection method, collected data using determined materials and procedures, tabulated data and observations made during data collection, calculated those results, and then discussed and concluded the results obtained. The location selected for the study was the Ninso Junction. It faces heavy traffic during peak hours, and the data was collected within 30 meters of the intersection. Two methods were used to collect the data. First was the manual data collection, and then the integrated camera data collection. For the manual data, a simulation model was created using the factors in the traffic. Variables included in the simulation model was the queue distance, the control, LOS. For the integrated camera, video cameras were set up at the junction, and 1 hour of recording was conducted, and observations made from the video was observed and analyzed. For the analysis method, several methods of analysis we used. The data collected was tabulated and categorized in order to organize the findings and results. Vehicle types are organized with each lane having different tables for the vehicle types, and the equations and formulas were used to analyze findings.
Hi everyone, my name is Mama Fahmi. Today I will dive into the heart of traffic dynamic at a critical four-way intersection near Ninso in Pait Raja Batu Pahat, Johor. Our journey begins in the north direction at Jalan Kuang. Here we observe the traffic flow in three lanes, left, right, and straight. The numbers tell a story. By calculating the passenger car unit (PCU), we get a clearer picture. The PCU account for the varying impact of vehicle classes in the north direction. The total PCU sums up to 523, reflecting the overall load on the intersection. Now, let's turn our attention westward onto Jalan Baru. The left lane witnessed 130 vehicles, while the right lane had 96 vehicles in the same direction. Heading south on Jalan Kluang, we observe diverse traffic pattern in the left, right, and straight lanes. The left lane saw 336 vehicles, the right lane 224, and the straight lane 368. PCU calculations reveal a comprehensive view: 318 PCU, 203 PCU, and 420 PCU, respectively. Lastly, the east direction on Jalan Parit Raja Darat, where the left lane experienced 176 vehicle and the right lane saw 240 vehicles. The PCU values for the east direction stand at 166 PCU in the left lane and 257 PCU in the right lane. That's all from me. Until next time.
Hi and good day. My name is Arifan Academic Abu Bakar and I will present for the analysis and result chapter. In this chapter, it is consists the determination of the signal timing and also LOS determination. In order to find the signal timing, it is important to first determine the Y value. For the phase 1, the Y value is critical Y value is 0.1548. Phase 2 is 0.2427, phase 3 is 0.1253, and phase 4 is 0.1925, and the total Y is 0.7153. Next is to determine the total lost time per cycle L and also optimum cycle time C. Total lost time L is equal to 16 seconds and cycle length is 120 seconds. Next, we need to determine the signal setting, which is consists effective green time, actual green time, and also controller setting time. For effective green time, the result is okay because the total green time is equal to cycle length minus total lost time. And the controller setting time is K1 90 second, K2 31 second, K3 14 second, and K4 24 second. After obtain the controller setting time, we can make the timing schedule for every phase, like shown above. After we get all the parameter, we can finally make the delay calculation and LOS determination. And for the calculation, is shown as the table above. So most of the LOS is at D level. That's all from me. Thank you.
Assalamualaikum and a very good day. My name is Nur Shahira binti Mahyudin and I will continue the presentation with the discussion. So the experiment was conducted at the Ninso junction to monitor traffic flow and collect data, and every phase and lane observed different LOS as seen in the table. So most of the phases are D and E. Various factors may have affected study, including the location, weather, and apparatus. So, posted speed limit reduced reaction times and assisted in controlling speed. It was decided to be suitable. Several suggestions may improve traffic flow, such as artificial traffic light, which would decrease vehicle waiting time. Finally, the conclusion. So the objective were to regulate traffic signal time to improve the capacity and efficiency to road networks, as well as determine the flow of traffic, delay, and LOS at Nisu Junction. So posted limit at the intersection was 60 km per hour. However, pace, mean, median, and 85th percentile speed exceeded it, indicating it was suitable. Speeding was a serious issue at the intersection, and the LOS measurements helped identify the problem and provide more solution. Overall, most lead had low LOS with them require more improvement. That's all from us. Thank you.